Welcome back, grade 10s. So now we are going to look at the third function, which is the hyperbolic function. So we are going to learn about the graphs, which were called hyperbolic graphs. So we have a function here for the hyperbola that says y is equals to ax plus q. So we are going to look now at this function, which is y is equals to ax plus q. So we'll start now to explain what all these variables stands for, the a, the q. You remember in the previous video when we were studying the graphs, which are called the quadratic graphs, we also had the a and the q. We said that the a now represents the shape of the graph. For the quadratic equation, for example, if a is positive, we said now that parabola will be like a smiling face. It's going to point upwards. So this is the shape of the quadratic graphs, which with a positive a. But if a is negative, we said now the shape of the parabola will be facing downward, representing the sad face, for example. And we said there that the q represents now the y-intercept. You can lift this graph upward, you can lift it downward or shift it downwards. If q is positive, it is lifted up. If q is negative, it is shifted down. Similarly, for the hyperbolic graphs, the a, we said this a is also representing the shape, is the constant that affects the shape. If your a is positive for the hyperbolic graph, that means that the shape of your hyperbola will be positive. But if a is negative, then that means the shape of the hyperbola will be negative. Now, for a positive graph, when a is positive, now you must remember the straight line graph. It will be better for you to go back to this one to understand the hyperbola. For the straight line graph, if m is positive, which means if the slope is positive, now this is the straight line graph for a positive slope. It starts from the first quadrant and pass through the third quadrant. So also for the hyperbola, if the a is positive, then your hyperbola will be in the first quadrant and in the third quadrant. That's why you can see now this first part of the hyperbola is in the first and the second one is in the third quadrant. But we said for the straight line, if the gradient now is negative, if the gradient is negative, then that means that the slope of the graph, the slope of the straight line graph will be from the second quadrant to the fourth quadrant. So this is how it's going to look like from the second quadrant to the fourth quadrant. That is for the straight line if your gradient is negative. For example, you are given something like negative mx plus q. This one would be y is mx plus q. So the gradient here is positive, the gradient here is negative from the second quadrant to the fourth quadrant. So the hyperbola also, if a is negative, that means that your first hyperbola will be in the second quadrant, then the second part of it will be in the fourth quadrant. So you need to remember the straight line graph when dealing with the hyperbolic graph. If a is positive, first and third quadrant. If a is negative, second and fourth quadrant. Then we have this second variable which we call a q. Now the q now represents the horizontal asymptote. That means that you can also lift this hyperbola up or you can shift it downwards. For example, in this case, if I set this y is equal to a 1, or that q is equal to a 1, that means that this straight line asymptote, horizontal asymptote, at the beginning it was at 0 at the origin, but it was lifted now 1 unit up. That's why they drew it here, pass through the y-intercept, which is 1. So we call this one now the horizontal asymptote. That is the horizontal asymptote. Now your graph now, the hyperbolic graph, must not touch the asymptote or cut the asymptote. It must not touch the y-axis, it must not touch the asymptote. Also, the second graph must not touch the asymptote or touch the y-axis, but it must be in the first quadrant and the third quadrant. In this case, it was lifted 1 unit up. Also, for the negative one, you can see that Q is positive, so that means the graph was lifted maybe 1 unit or 2 units or 3 units, doesn't matter depending on what you were given in the graph. Sometimes they can give you y is equals to negative 2 over x, and they might set plus 1. That means it's lifted 1 unit up. Or maybe they might say you are given something like negative 3 over x, they said plus 2. That means it was lifted 2 units up. So we will deal with the drawing of the graphs later on. Now we are just trying to explain these variables. So these are the positive and the negative graph. What if now you are shifting the graph downwards? How is it going to look like? So let me show you. Now, if you have a graph now with Q that is negative, you can see now the Q here is negative. A is still positive, that means it's in the first quadrant and the third quadrant. But now Q is negative, that means now the graph has been shifted downwards. It can be 1 unit down or 2 units down, depending on what you are given in the equation. Then also for a negative graph, you can see here A is negative. That means the graph is in the second quadrant and the fourth quadrant. And you can see here Q is also negative. That means the graph was shifted now downwards. Here is the asymptote at the negative y-axis. It can be 1 unit, 2 unit, doesn't matter depending on the equation. But you can see that we can shift the graph downward. We can shift the graph upwards. So I'll do now an example where you are required now to draw the hyperbola, a positive equation hyperbola and a negative function hyperbola. Then on the third example, I will be doing now a question where you are given the shape of the graph itself, and they say to you, you must derive the equation from the graph. So let's look at now example number 1. We want to know now how to draw the hyperbolic graph for a positive one. So here is a question. This is example number 1. Sketch the following graph showing all intercepts with the axis and the asymptotes. You are given h of x is equals to 2 over x plus 1. H of x is equals to 2 over x plus 1. So we want to sketch this graph of the hyperbola. So the first thing that you have to do, you have to draw a Cartesian plane. Okay, so we'll be using now this Cartesian plane. So we have to draw now the Cartesian plane here. Then we are going to use it to draw our sketch our graph. So the first thing that you have to do is to find the coordinates. So I have this table here of x and y. So I'm going to use this table now to generate my outputs for y. So look at the graph. The A is positive. So you already know that if A is positive, that tells you that the shape of the graph will be in the first quadrant and in the third quadrant. That's what you know. But they also gave us a Q. They said Q is equal to a 1. So the first thing that we have to do is to draw now this asymptote at 1. So let me fill this Cartesian plane with numbers. Then we are going to show you the asymptotes. Okay, so this is our Cartesian plane. So on the right hand side we have positive x-axis, on the left hand side negative x-axis. Up here we have positive y-axis, down we have negative y-axis. So the first thing you have to look at is the Q. the graph is lifted 1 unit up. So you have to draw now this horizontal asymptote at Q. Remember, Q represents y-intercept. So we are looking at y is equal to 1. This is the point where y is equal to 1. So we have to first draw our horizontal asymptote passing through the point which is 1 on the positive y-axis. So this is the first step that you have to do. Draw that horizontal line, which is the y-intercept. So that is your Q equals to a 1. So I've dealt with that one. Now we need to find our points, which is the x and the y coordinates. So since we are given a is equal to 2, I'm going to have my inputs now from 2, then I go 1, I go negative. Okay, let's start on the negative side, then you go to the positive side. So let's say this is negative 2, negative 1. Now you don't have to put a 0 here because you cannot divide by a 0. That will be error. So we can go negative 2, negative 1, positive 1, positive 2. Yeah, we can just take these two inputs, these two negative inputs and two positive inputs. Now, if you take the negative 2, which is my x, you substitute it here. Negative 2 divided by negative 2 divided by negative 2, that's negative 1. Negative 1 plus 1, that's going to give you a 0. If you take negative 1 and substitute here in place of x, 2 divided by negative 1, that's negative 2. Negative 2 plus 1, that's going to give you a negative 1. Now, if you take a 1 and then you substitute in place of x, 2 divided by 1, that's a 2 plus 1, that's going to give you a 3. If you take a 2 and you substitute here, 2 divided by 2, that's a 1 plus 1, that's going to give you a 2. So we have these 2 points now, x and the y, x and the y, x and the y, x and the y. So we're going to first plot now the first 2 points. The x is negative 2 and the y is 0. So the x, here is the x, which is negative 2. And the point where y is 0, this is the point where y is 0. So the first dot now that we have is here. I'm going to make it big. So we have now the first coordinate, which is 2 and 0. I'm looking at the second one now. I'm here. I'm looking at negative 1 for x, negative 1 for y. So the second coordinate, x is negative 1, here is negative 1. Y is also negative 1, here is negative 1. So they meet at this point. So that is my second dot. Then I go to the other side. I look for x is 1 and y is 3. This is x is 1 and y is 3. This is y is 3 and x is 1. So that is the first dot on the other quadrant. Then I'm looking for the last one, which is this one. 2, x is 2, y is 2. This is x is 2, y is 2. So this is my second dot. So now I have to plot now my graph. I have to join these 2 points. 2 on the quadrant 1, 2 on the quadrant 3. So now I have to join this. But you must make sure that your graph must not touch the asymptote, which is the horizontal asymptote. It must not also not touch the y-axis. Okay, so this is our second example. Y is equals to negative 3 over x minus 1. So we are also required to sketch this one, draw this graph. So the first thing that you have to check is what is A. A is a -3, so that means A is a negative value. So that means the shape of the graph now will be in the second quadrant through the fourth quadrant. That's the first thing. Now we must go and draw our asymptote. This is a negative asymptote. That means the graph was shifted downward 1 unit. So at -1, I have to draw my asymptote. So this is my horizontal asymptote passing through -1 because it was shifted downward. Yeah, you'll take a ruler and then you draw that line. Now I'm going to find my points x and y. So the A is -3. So I'm going to start, say I have -3, -2, -1, 0, 1, 2, 3. So I have these inputs, which is -3, -1, 1 and 3. So the reason I'm skipping 2 is because I don't want to have a, what do you call this, a decimal number. For example, you are given -3 over x minus 1. If you put a 2 here, then you're going to have -3 over 2 minus 1, which is -1.5 minus 1. So -1.5 minus 1 is going to give me -2.5. I don't have the points here on my graph where I can identify where is -2.5. I have to assume now. So I don't want these points like the decimal points. I just need whole numbers. That's why I am skipping 2. I'm also skipping 2 there. Yeah, so it's up to you. If you want to put the 2's, you can. Now let me go and find my outputs. So I'm given the input. Now I have to find the outputs. Okay, let's take this -3. We said -3 divided by -3, that's going to be +1. +1 minus 1, that's going to give us a 0. Let's take now the second input, which is -1. If you substitute -1 here by -3 divided by -1, you're going to get +3 minus 1. It's going to give you a +2. If you take 1, substitute here in place of x, -3 divided by 1, that's going to be -3. -3 minus 1, that's going to be -3. Yeah, -3 minus 1 is going to be -2. Then you take now the last one, which is 3. If you set 3 divided by -3 divided by 3, that's going to be -1. -1 minus 1, it's going to be a -2. Yeah, so these are my coordinates: first coordinate, second coordinate, third, and the fourth. So I want to go and plot now all these coordinates. So I look at the first one. We have -3, x is -3, this is -3, and the y is a 0. So this is x is -3 and the y is a 0. I'm gonna make that first big dot there. Remember, it must be on my second quadrant, the other one fourth quadrant. So I'm looking at the second points. X is -1, y is 2. Here is x -1, here is y is 2. So the second dot is going to be here. So I'm done with the second quadrant. Now I'm going to the fourth quadrant. So I'm looking at the third coordinate. X is 1 and y is -2. This is x is 1, this is y is -2. So I'm looking at this point. So this is my first dot on the fourth quadrant. I'm looking at x is 3 and y is -2. This is x is 3. This is y is -2. Okay, wait. Let's check something here. Yeah, I think I made a mistake here. Let me quickly fix it, because you can't have points that are parallel. Okay, yeah, it was my mistake. Where we are supposed to take 1 and divide here, we're going to have negative 3 divided by 1. That's supposed to be negative 3 minus 1. So negative 3 minus 1 is negative 4. Yeah. So I can see now I made a mistake. Then if you take a 3, negative 3 divided by 3, that's going to be negative 1. Negative 1 minus 1 is negative 2. Yeah, you have to use a calculator to do those outputs, né? So that you don't make a mistake like I did. Yeah, so let's correct this one. So this coordinate is x is 1 and y is negative 4. That's x is 1 and y is negative 4. Yeah, the point is here. Then the last one, x is 3 and y is negative 2. This is x is 3, y is negative 2. You are looking at this point. Yeah, now we are done. So we have to now join these 2 points and make sure we must not cut or touch the y-axis. We must not cut or touch the asymptote. This is our asymptote. Q is negative 1. So we have to join now the points. So let me join now these 2 points. Yeah, this is how your graph is going to look like. So this is the first, second quadrant. This is the fourth quadrant. You can see that my graph is not touching the asymptotes. It's not touching the y-axis. Yeah, so this is the shape of the graph, the negative graph, and it is shifted downward for 1 unit downwards. Yeah, so we are done now with the drawings of the graphs. So now I want to give you an example where you are given the graph and now you have to derive an equation based on that graph. For the past 2 examples, we are given the equation, we have to draw the graph. Now you are given the graph, you have to discover or determine the equation. Okay, this is the third example. So the example is saying, yeah, determine the equation of a graph. So you are given the graph now. As you can see, this is a positive graph because of it's from the first quadrant to the third quadrant, from quadrant 1 to quadrant 3. So you can see that this is a positive, a hyperbolic graph. Then you can see now the asymptote is in 2, is passing through 2. So Q is 2 or Y is 2. So we already know Q, it is lifted 2 units upwards. This is a origin, or that is 0. So the graph is lifted 2 units up. So let's find the equation now. So I'm going to say my equation is y is equals to a over x plus q. Because if I know that this a is positive, because the shape of the graph is positive, I already know the q is 2. So let me substitute for what I know. So I know q is 2. So I have y is equals to a over x plus 2. I already know q is 2. Now I need to find y and I need to find x. In fact, I am given x and y, but I need to find a. Remember, this is the point that you are given on the graph. The point is 4 and 3. Your x is 4, your y is 3. So I'm given the point that I'm going to substitute for y and x, so I have to find a. So I will substitute 3 for y. I will substitute 4 for x plus 2. So I need to find now a. So how to find a? Let's take the 2 that is on the right to the left. So I'm going to have 3 minus 2 equals to a over 4. Then what is 3 minus 2? That's a 1 equals to a over 4. Then I have to cross multiply because this 1 is over 1. 4 times a 1, that's a 4. Cross multiply. So we take this denominator, we said 4 times 1, that's a 4. A times 1, that's a. Then 4 times 1, that's 4. So that means that a is equals to a 4. So that means we are done now. The equation is y is equals to 4 over x plus 2. Yeah, so that's how we determine the equation of the graph or the function of the graph. We started first by identifying q. We said q is 2 because the graph is lifted 2 units up. Then we said let's take this point that is given to us on the graph. Let's substitute it for y and x. Then we went to find a. We discovered a is 4. Then we substituted a in our equation. So the graph is y is equals to 4 over x. Yeah, so we are done now with the hyperbolic function or the hyperbolic graphs. So in the next video now, which is the last video, I'll be doing now the exponential graph. And then I'll do another video where now you will be answering exam questions. We want to see now how they will assess us on this topic of the function in the exam question papers. Yeah, so this is the end of this video.